Okay, everybody, let's see how this review goes. I'd like to go through these problems with you just because it's kind of on a short kind of turnaround here between giving you the review and working with the test. Without further ado, let's go ahead and look at some of these problems because we didn't have a whole lot of time to get through them through the class time. So, number one, jet ski company charges a flat fee, $34, $2 an hour to rent the jet ski. Another company charges the fee. I think you guys know how this goes. Notice the problem is asking us to figure out, find the number of hours which the costs are the same. Pretty typical system question. First move, figure out the equation for the first company. So $35 plus $2 per hour to rent the ski. Jet ski, pretty simple from there. We could write this very easily. Y must be equal to your $34 plus your $2 per jet ski. We can just call it 2x. Notice right after that, we have next $27.75 plus $3.25 per hour. We could write that one pretty easily as well. So here's your other one, $27.75 plus $3.25 times x. So we're trying to figure out when they're the same. Nice thing is we have y being equal to this guy right here. Y is also equal to that guy right there, so we can easily assume that they must be worth the same amount, and we can set them equal to each other. So 34 plus 2x must be equal to 27.75 plus 3.25 times x. So we're pretty much just solving this algebra problem. You're probably going to want to keep those variables positive, so the best way to do that would be subtracting the 2x from both sides of the equation. Once we do that, now I'm staring at 34 being equal to $27.75 plus, and this would be 1.25 times x. Next move, let's subtract the 27.75 from both sides. And let's figure out what we got from there. So that would give us $6.25 being equal to 1.25 times x. Finishing move here, dividing both sides by 1.25, divide by 1.25, and then we get our answer here that x needs to be equal to 5. In other words, for those two companies to charge the same amount, it would have to be 5 hours. A couple of other ways I can see us definitely doing this problem. We can definitely take this problem apart using your graphing calculator, because if you notice right up here, we do have two equations that are in slope-intercept form. So we could just take those two and put them in slope-intercept form, just like that. And then we could graph them to figure out where they cross, but you might notice something kind of strange might happen when you graph them. Whoa, that's kind of weird. But remember, the y-intercept for each one of these is pretty high. We have a 34 and a 27.75, so when your viewing window goes all the way up there just to 10, it can't really fit. So you could adjust the viewing window. And to do that, right at the very top of your calculator, you'll see a zoom button. Press that zoom button, go all the way down to choice 0, and you'll see something that says zoom fit. Usually zoom fit is a nice one when you're trying to figure out the intersection point and you can't find it on the graph. So after me pressing zoom fit, we get a nice looking graph right there, and boom, you can see that intersection point right there. So how you can get that intersection point quick, fast, and in a hurry, go ahead and press the second button. Then press trace, select number 5 for intersection, and then you can press enter, enter, enter one more time, and then there's your solution here. Not only are we seeing that it's 5 hours, but they're also giving us the total cost right there of $44 would be the cost of both of those companies. Remember, if you were typing that into your graphing calculator and you had it right here, you could also just go to the table of values by hitting second and then graph. And then if you notice right down here at 5, you see that's where both those costs are the same at 44. So the correct answer there would have been 5. So there's just another way you could have done that problem. Alright, moving along, let's take a look at these two here, stating the solution. Like I said during class, I'm not too concerned about which way you solve it. What I am concerned about is making sure you have the most efficient way of solving these problems. Looking at this particular problem, I think elimination would be a great way to solve this one. If we take this entire equation right here and just multiply everything by 2. And so if we multiply each one of these, including that guy right there, by 2, I'll write it right directly underneath. So 2 times negative 2x, that should give us negative 4x. 2 times 2y should give us a positive 4y, and 2 times 5 gives us 10. Add those up, because now we can do elimination here. The x's would eliminate to 0 x's, and then we'd have 0 y's, and then over here we'd get 0. So ultimately, we are here. We are here at what would be a true statement. 0 is always equal to 0. So the solution that we would have here would be infinitely many solutions. Alright, how about the other one? Hey, notice this one, it's already good to go for elimination. So how about we just go ahead and eliminate right now and add those up. 2x, negative 2x, goodbye x's, y's and 1y and negative 1y, add those up, goodbye. And so over here we're going to have a 0, just like we had a 0 right here in that situation. And then 11 plus 8, that gives us a 19. 0 is never equal to 19. We have a false statement there. So in this case, there would be no solution.